Hey guys, 0101 here with a new update for my ALU. Let's do a little explanation first. Alright, so when you're running a program, you have to load wherever the program starts into some sort of a memory location. Then after every step, like once it completes that instruction in that memory location, then you have to increment it and then pull the memory from the next location, and then that's how you get the program to run through. So the biggest thing was trying to figure out how to do that, in Minecraft and programmatically and all that other good stuff. So it took me, I don't know, like a week, but I finally figured it out. You'll see that there are some new types of circuitry in here that I haven't used before. That's because there were some inadequacies with the stuff that I was using before that it wouldn't really work for this. So I had to do some research, and YouTube is my new best friend. So let's get started on this. I'll explain what all this is. Okay, now these right here are going to be like, let's say that you have a program that starts in memory location 0, right? So 0, 0, 0, 0. So you'll set all these to 0, and then you'll upload this thing, and then this is what it's actually reading out right now. So I mean, right now it's already good. But if you need to, let's say that it starts at memory location, I don't know, 8, right? So we'll hit that one. And then this button right here is what it's actually the override for this whole thing. So it'll force data into my little data holders, and then it'll export that onto these 4 lanterns right here. So do that. And there we go. So now we have memory location 8 loaded. These are backwards, or reflective, mirrored, whatever you want to call it. Okay, so you've seen some T flip-flops that look, let me see, I'll build one up real quick. Yeah, they look like this, right? So you put something in there, and then you put a button down here on this. Oops, sorry. There we go. And then every time you click this, it forces the thing through, and then that lights up. I haven't put anything in there, which is why it's not working. But the issue with this is it's glitchy. I mean, it's not as guaranteed. So like when you have a bunch of inputs going into this thing, I mean, it may not function the way it's supposed to. And for something like this, where I want it to be completely automated, it needs to be 100% all the time. So I looked up some stuff, and this is kind of what I came across. So it's a sticky piston here, and it's got a redstone block here, redstone torch here, 2 layers or 2 things of redstone dust, and then another one over here. And then all you have to do is hit that button right there, and then it'll force these to switch this over. And then on the other side, we actually pull the information off of only one side. So when the redstone block moves over there, then this is off. When it moves back over to here, then it's on. So it's just it's a T flip-flop. It's guaranteed 100%. I haven't had any issues with it whatsoever. So what I've got here is this first one right here will be set at the clock pulse or whatever, and then it'll go through here. And then this is a little pulse generator type thing. And we actually have the override, which is coming through back here, going up onto here. So this is what sort of activates the button, only from other stuff over there. So it goes through here, then it goes through here, and then this piston right here acts like a switch. So that way when you're overriding this, and you set this through, and if this switches to a 1, it actually doesn't send the signal through to the next one. Because I mean, this is all cascaded. So when it's hooked up, whenever one of these changes, then it'll actually change the next one. And it's, just a counter. So I didn't want it to, input or change the next one in case I'm like trying to set like a 0 onto this one and a 1 onto this one. Then as soon as you set it through, then it sends a 1 through, and then this one becomes a 1 instead of a 0, and it's just a big headache. So I had to be able to turn off the cascade in order to set everything manually. Okay, so now this signal right here is a 1 here, it's a 1 here, and then up here on the torch it's a 0, but at this block right here it's still a 1. So I pulled redstone off of here, and it goes through because of the repeater right there. And then I inverted this signal. These actually work inverted, so once you invert it, it goes into normal binary. And then I have the signal going through here, which goes out onto here, and then I also have it going over to here, which will then put it through over onto this thing. Now this is an XOR gate without pistons. It's about the same size as the one with pistons, and it works very, very well. So to do this one, you've got 9 blocks on the bottom, 8 blocks on the top, 1 in the middle is missing. Torch here, redstone, 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 torch, 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 repeater, repeater, and then your output is actually right here. So when one of these, like let's say this one is on, then this shuts off, and then it goes over here, shuts that one off, and it works. We'll just leave it at that. And we have the other going into here. The reason why it had to be an XOR gate is because let's say that this has a 0, right? And I want to try to set a 0. Well, I mean, if it's already set to a 0, I don't need to change anything, right? So if you're thinking logic table, you know, if you have a 0 and a 0, then I need to make no change, so that has to be a 0. But then if one of these is on and one of these is off, let's say I want to set a 1 and this is at a 0, so then a 1 and a 0 has to equal a 1. And then if this is off and this is on and I want to set that as a 0, then a 0 and a 1 equals a 1. But then if they're both off, like they are right now, or both on, then I need that to do nothing, which is a 0. So the truth table would be 0, 0 equals 0, 0, 1 equals 1, 0, 1, 0 equals 1, and then 1, 1 equals 0. So if you look up that logic gate, then you'll see that it's an XOR. So that's why I had to use that. And then in order to keep this from going through every time this changes, I had to put another piston right here, and this just acts like another switch. So that just opens it right here. So whenever this changes, it actually doesn't go through unless I want it to. So then that switch there and this switch here are all controlled off of this main line right here, and that just goes all the way through. I had to put some repeaters here in front of this piston because this would open back up too quickly, so when this changed to a 1, it would send a pulse through, but then this would already be in place, it would actually send the pulse through, so I needed to slow this down, which is why those repeaters are there. And then, you know, basically it just goes through the T flip-flop onto the pulse generator, through the switch, and then onto the next one, and then just repeats the process all the way through. So yeah, you should have seen some of the ones that I had before. They were massive and they still didn't work, so I'm actually kind of surprised that this is only 7 blocks wide, which is good because it's more compact. The other ones I think were like 8 and 10 blocks wide, which was too big. But yeah, and then we'll just do some regular counting. So we're at 8 already, so hit that one. Now we're at 1. Now we're at 2, 3, 4. I'll just bring it all the way to 0. There's that one, and that one, and that one. Okay, so now these are all 0. Now let's say that I want to start at memory location 15, or 16, whatever. 15 if you're counting in hex, but it's actually the 16th one. So then we're just going to go and set those all the way through, and there you go. It's set. And then if I want to set these all back to 0, then I just have to do that, hit the button, and they are all set back to 0. And then the incremental will start off from wherever the memory is. So yeah, all I have to do is just put another 4 onto here, and then I will be able to access all of that stuff right there. Alright, so that's the video. If you have any questions, feel free to ask. But yeah, I think with this I can move on to working with the controller, which is going to be the next big project. Now it's probably going to take me even longer than this one to figure out. So, hope you enjoyed the video, and I will see you guys later.